Our next presentation will be by one of our students, Robert Wooldridge. Robbie, take it away.
Thank you, Dr. Thompson. Hello, everyone. My name is Robert Wooldridge, and today I will discuss with you all aquaponics on this campus and abroad. So currently, 54% of the world's population lives in urban areas. 68% of the world's population is projected to live in urban areas by 2050. This shift will create many problems, including the means in which people obtain food. As population density increases, cities must import crops in order to feed their residents. The import and transportation of crops increases the carbon footprint as well as their cost. This trend makes urban farming that much more imperative. By growing crops in an urban environment, society can reduce the carbon footprint and the cost of goods. Now, urban aquaponics offers a unique solution to this problem. Now, how exactly does aquaponics system work? Aquaponics uses a symbiotic relationship between fish, earth, and vegetables to create an extremely sustainable environment to grow crops. This system mimics a natural waterway. An aquaponics system starts with a tank where the fish reside. This tank also contains nitrifying bacteria that clean the water and also turn the fish waste to nitrate. This water is then slowly pushed into the plant system, and the plants absorb these nutrients and create food. This system, if in working order, creates a cycle that produces quality organic fish and vegetables, and with minimal impact for the environment, and there's a very low input. So Engineers for a Sustainable World, Seattle University has created one such system in Manchay, Peru. This system allows for the growth of both fish and vegetables in a hospitable environment and reduces the cost of vegetables in the local community. ESW plans to travel back to Manchay in the fall to create an even larger system. This system will allow for communal growth of crops and decrease in the cost and use of resources. So as a club, we've been planning to create a much smaller system in Seattle, both to prove the benefits of this system and the feasibility of creating a larger system on campus. This small system would need to be indoors due to the climate of the area and preferably be mobile for even easier management and presentability. The ideal system for Seattle University would fill an entire greenhouse and produce enough vegetables and fish to beneficially impact the carbon footprint of the entire school. So an aquaponics system on campus would offer quite a few benefits, including low power and water usage. The primary input is only fish, food, and water. There's little to no chemical usage. The plants that thrive in aquaponics systems grow extremely easily. There's a very low risk of pests and diseases. The crop turnaround of these systems is extremely high. There's a very increased crop production per square foot compared to traditional farming, and a variety of fish and crops can be grown in these systems. So when we compare this system to the 3 pillars of sustainability, for social, aquaponics creates a connection and conversation about the food we eat. For environmental, aquaponics lowers the carbon footprint of crops. And finally, for economical, aquaponics lowers the cost of both vegetables and fish. So in conclusion, aquaponics offers a unique solution to providing people in urban environments with food. Urban aquaponics farming will cut both the costs and the carbon footprint of providing food with the social benefit of growing food for oneself. As urban America continues to grow, Americans need to find a more economical and less ecologically taxing method of production. An aquaponics system would be a great start and help create a community based around the growth of our food and our sustainability.